Hello grade 8! Are you ready for a new math adventure today? Join me in discovering two types of reasonings in math: inductive, deductive. Before discussing, let's have a fun activity first. Minute to win it. Observe the statements if they are both logically and realistically true. Statement number 1. RA 7610 is a law that protects children from abuse, exploitation, and discrimination. Forcing a child for employment is an abuse and it is punishable by the law. What do you think? Is this both logically and realistically true? Share your opinion about this matter. I'm giving you 30 seconds to think and answer. Statement number 2. My math teacher in Sampaga High School last school year is awesome. My math teacher in Sampaga High School this school year is awesome. Therefore, all math teachers in Sampaga High School are awesome. What do you think? Is this both logically and realistically true? Share your opinion about this matter. I'm giving you 30 seconds to think and answer. Remember your answers, okay? The two statements are concluded in different ways. One is inductive, the other one is deductive. Inductive and deductive are methods of reasonings in mathematics. Inductive reasoning is logically true, but may or may not be realistically true. That means it is not yet proven. It could be true to you, but not to others. Also, it gives specific examples before coming up with the general conclusions. While deductive reasoning is logically and realistically true, it is always true to everyone. It is based on facts, research, and studies. It is being started with the general conclusions and then gives a specific example. Now let us see if your answers are correct. Statement 1 is both logically and realistically true, because indeed it is a law and applied to everyone. Therefore, it is an example of deductive reasoning. Statement number 2 is logically true, but may or may not be realistically true, because others may agree that math teachers in Sampaga High School are awesome. However, others may disagree. Grade 8, in math, these reasonings are applied to the formal theorems and proofs that we rely on today. All began with these two types of reasoning. Even today, mathematicians are actively using these two types of reasonings to discover new mathematical theorems and proofs. In science, inductive reasoning has its place in the scientific method. Scientists use it to form hypotheses and theories. Deductive reasoning allows them to apply theories to specific situations. Believe it or not, you yourself might be using inductive and deductive reasoning when making assumptions on how the world works. Are you now ready to be amazed on how it works in the world of mathematics? Let's dig deeper. Let's learn math in science way. Here is your task. Find out if the books in the box are all Math 8 books. Step number 1. Pick up one book and check if it is a Math 8 LM book. Let us say that the first book we have observed is a Math 8 LM book. Step number 2. We will pick another book from the box. Let us say that the second book we have observed is also a Math 8 book. Step 3. For the third time, let us pick a book again from the box. Let us say that the third book we have observed is still a Math 8 book. Based from the 3 books we have observed, many of us will now conclude that all the books in the box are Math 8 books. So, what did we do? We have observed and examined just 3 out of 8 specific books from the box. And then, we arrived to the general conclusion. Our conclusion is that all the books in the box are Math 8 books. By observing specific samples from the experiment, we had the general conclusion. And this is specific to general approach of reasoning is called inductive reasoning. And now let's have it clear. Observe the following statements. Statement 1 and 2 are specific and logically true, but look at the third statement. Statement 3 may or may not be realistically true. The box may contain daily books or other books which are at the bottom part. This is inductive reasoning. On the other hand, we have deductive reasoning, in which the approach starts with a general argument to specific conclusion. Observe the following statements. Statement 1. All books have pages. Statement number 2. Math 8 LM is a book. Statement number 3. Math 8 LM has pages. All statements are logically and realistically true. That means it is definite and proven. Statements 1 and 2 are general. Then we had a specific conclusion in statement number 3. This general to specific approach of reasoning is what we call deductive reasoning. Let's learn more. Did you know that inductive reasoning is frequently used in mathematics? By observing a pattern in a particular case, a general conclusion can be induced. A conclusion that is based from inductive reasoning is what we call a conjecture. A conjecture is a mathematical statement that has not been proven yet. Conjectures arise when one notices a pattern and true to many cases. However, just because a pattern holds true to many cases, that does not mean it holds true to all cases. And when a conjecture is proved, it becomes a theorem. Inductive reasoning in math. Example number 1. Number pattern. Guess the missing number. Letter A. 1, 3, 5, 7, 9, blank. What's the missing number? You may pause the video to think. And the answer is 11. Because the numbers are consecutive odd numbers, then the next number is 11. Letter B. 2, 4, 8, 16, 32. Blank. What's the missing number? I'll give you a few seconds to pause the video to think. And the answer is 64. You may find the next number by multiplying the preceded number by 2. That is, 2 is our first number, then multiplied by 2, we got 4. Multiply again by 2, we got 8. Multiply again by 2, we got 16. 16. We multiplied by 2, we got 32. And finally, we multiplied by 2, we got 64. Letter C. 1, 1, 2, 3, 5, 8, blank. What's the missing number? I'm giving you a few seconds to pause the video to think. The answer is 13. You may find the next number by adding two preceding numbers. That is 1 plus 1, 2. That's why the third number is 2. To get the fourth number, we add the second and the third. 1 plus 2, 3. And so on and so forth. Visual pattern. Example number 2. Observe the two images and find what might be the third image. Pause the video and think. By applying inductive reasoning and observing the images, we can assume that the next image will be finding a conjecture or syllogism. Example number 3. Bern went to Sampaga High School and observed that each student she came across with has a calculator. No matter what grade level they are in, all students have a calculator. What can be conjectured from this? Pause the video and think. Our conjecture would be each student in Sampaga High School has a calculator. Example 1. Statement 1. Acute angles are angles whose measure is greater than 0 but less than 90 degrees. Statement 2. Angle M measures 56 degrees. Statement number 3. Therefore, angle M is an acute angle. Statement 1, we have the definitions of acute angles. And statement number 2, we notice that the given measure is under the definition in statement number 1. Therefore, in statement number 3, we conclude that angle M is an acute angle because it has a measure of less than 0 but greater than 90 degrees, which is 56 degrees. Example number 2. Statement 1. Rational numbers are numbers that can be expressed as a quotient of two integers in the form a over b. Note that both a and b are integers. Statement number 2. Full numbers, let us say 5, can be expressed as 5 over 1. Statement 3. Therefore, full numbers are under the family of rational numbers. Now your turn, let us practice. Predict the next number applying inductive reasoning. Complete the statements applying deductive reasoning. After practicing, here are the glittering ideas. Thank you so much for listening, grade 8. Happy learning!